Hello students, in this video we will quickly revise chapter triangles. We will solve few previous year questions and a few questions from NCERT. What do you mean by similarity? If you take two triangles here, we will take triangle ABC and another triangle PQR. Okay, here we are taking two triangles and the angles are 60 degrees, 70 degrees and 50 degrees. Okay, and in this triangle the angles are 60, 70 and 50 degrees. Okay, now if you see angle A is equal to angle B, it is 60 degrees, and angle B is equal to angle Q, it is 70 degrees, angle C is equal to angle R, it is 50 degrees. Now the corresponding angles are same. If the corresponding angles are equal, then we say the two triangles are similar. Okay, so here triangle ABC is similar to triangle PQR. Okay, we have to write the correct order here. See here, A is equal to P and B is equal to Q, C is equal to R. We should not write ABC is similar to triangle QPR. This is wrong. We have to write the correct order. This is the correct one. If the two triangles are similar, then the ratio of the corresponding sides is equal. That means AB divided by PQ. Okay, see here, first two alphabets AB divided by PQ is equal to second two alphabets is equal to BC divided by QR is equal to AC divided by PR. AC divided by PR. Okay, so we have to write the correct order or else you will get the corresponding ratios wrong. Okay, and what is the difference between congruency and similarity? See, in this similarity, the corresponding angles are equal and the ratio of the corresponding sides are same. Okay, but in congruency, the corresponding angles are equal, and the corresponding sides are also equal, then we say the two triangles are congruent. Okay, theorem 6.1. This theorem is very important and it is asked so many times in the board exam. Okay, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Okay, see here we will take a triangle ABC. ABC is a triangle. Okay, if a line is drawn parallel to one side of the triangle, see, we will draw a line DE parallel to BC. Okay, and to intersect the other two sides. So here DE is intersecting AB and AC at D and E respectively. Okay, so the other two sides are divided in the same ratio. So AB and AC are divided in the same ratio. That means AD divided by DB is equal to AE divided by EC. Okay, you should definitely learn the proof of this theorem. Now we will see how do we prove this theorem. First, we will take two lines EX and DY. This both are perpendicular to AD and AE respectively. Here we will take XE is perpendicular to AD and DY is perpendicular to AE. Okay, so what is the area of the triangle ADE? Area of the triangle ADE. We will take AD as the base. Okay, area of the triangle is half into base. Base is AD. Okay, into height. Height is XE. See here, XE is perpendicular to AD. So XE is the height. Half into BH is the area of the triangle. Okay, and now we will join BE and CD. Okay, and now we will take the area of the triangle DBE. Area of the triangle DBE. What is the area of the triangle DBE? It is half into base. Base is DB. Okay, it is DB into height. Height is XE. Okay, height is XE. And now we will divide these two. Half and half will be cancelled. XE and XE will be cancelled. We will get AD divided by DB. Okay, and now again we will find out the area of the triangle ADE. Area of the triangle ADE. And now we will take the base as AE. We will take the base as AE. It is half into base. It is AE into height. Height is what? It is DY. Okay. And we will find the area of the triangle DEC. We will find the area of the triangle DEC. It is half into base. Base is EC. Okay. EC into height. It is DY. And now we will divide these two. Half and half will be cancelled. DY and DY will be cancelled. we will get AE divided by EC. And if you see these two triangles DBE and DEC, if you see these two triangles are lying on the same base DE. See the triangles DBE and triangle DEC. Okay, these are lying on the same base, that is DE. Same base DE. And these two triangles are lying between the parallel lines DE and BC. These two are lying between the parallel lines DE and BC. Okay, so the area of these two triangles are same. So the area of these two triangles are same. We will take this one as first equation and this one as second equation. Okay, and area of the triangle DBE is equal to area of the triangle DEC. So here we will take area of the triangle DEC is equal to area of triangle DBE. Okay, so from first and second equations we have area of the triangle ADE divided by area of the triangle DBE. Okay, we have the same in the second equation. So from first and second equation we have AD divided by DB is equal to AE divided by EC. Okay, see this is the ratio of the sides. AD divided by DB is equal to AE divided by EC. Okay, DE divided these two sides in equal ratio. Okay, next one, theorem 6.2. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. See, this is a triangle ABC. Okay, so this is a line DE. This divides the two sides AB and AC in the same ratio. That is, AD divided by DB is equal to AE divided by EC. Okay, then DE is parallel to BC. Okay, this is theorem 6.2. You have to remember this. Now we will solve few questions. First one, if a line intersects AB and AC of a triangle ABC at D and E respectively. Okay, this is the triangle ABC. This is triangle ABC. And if a line intersects AB and AC. Okay, so this is the line DE. It intersects at D and E respectively and is parallel to BC. We have to prove AD divided by AB is equal to AE divided by AC. Okay, we have to prove this one. So by theorem 6.1, what is theorem 6.1? If a line is drawn parallel to a side of a triangle, then the line divides the other two sides in the equal ratio. That means AD divided by DB is equal to AE divided by EC. Okay. So this is according to the theorem 6.1, and we will take inverse of numerator and denominator. We will get DB divided by AD is equal to EC divided by AE. Okay. Now we will add 1 on both sides. Add 1 on both sides. We will get DB divided by AD plus 1 is equal to EC divided by AE plus 1. Okay. If you take LCM, you will get DB plus AD divided by AD is equal to EC plus AE divided by AE. Okay. What is DB plus AD? DB plus AD is what? It is AD. It is AB. AB. AB divided by AD is equal to EC plus AE. It is AC divided by AE. Okay. And now we will take the inverse again. Numerator will go to denominator and denominator will go to numerator. Okay. We'll get AD divided by AB is equal to AE divided by AC. Okay. Next one, in the figure, DE is parallel to AC. DE is parallel to AC and DF is parallel to AE. DF is parallel to AE. We have to prove this one. Okay. See, if you see the triangle ABC carefully, DE is parallel to AC. This DE is parallel to AC. Okay. If you see like this. Okay. Here DE is parallel to AC. Okay. And here it is B. See here DE is parallel to AC. So So DE divides BA and BC in equal ratios. So BD divided by DA is equal to BE divided by EC. Okay, and DF is parallel to AE. DF is parallel to AE. So if you see the triangle ABE, okay, see this is for triangle ABC. In triangle ABE, DF, this is D, this is F. DF is parallel to AE and here it is B. Okay, so DF divides AB and BE in equal ratio. So we will get BD divided by DA is equal to BF divided by FE. Okay, see here we have BD divided by DA and BD divided by DA. We have this ratio same. So we will equate the first and second equations. We will get 1 is equal to 2. Here BE divided by EC is equal to BF divided by FE. Next one, in the given figure, E is a point on side CB produced of an isosceles triangle ABC with AB is equal to AC. See here AB is equal to AC. So the angles opposite to equal sides are equal. So angle B is equal to angle C. If AD perpendicular to BC, see AD is perpendicular to BC and EF perpendicular to AC. So these both angles are 90 degrees. Prove that triangle ABD is similar to triangle ECF. Okay. So first we will compare the triangles ABD and triangle ACD. Okay. See here angle D is 90 degrees. Angle ADC is 90 degrees and angle ADB is 90 degrees. Okay. And angle B is equal to angle C. So the third angle will be equal. So angle BAD is equal to angle DAC. Okay. And angle B is equal to angle C. Okay. And AB is equal to AC. Okay. So by using angle side angle property, we can say that triangle ABD is congruent to triangle ACD. Okay. And now we will compare the triangles ADC, triangle ADC and triangle ECF. Okay. See here angle C is common. Angle C is same. Okay. Angle C is common and angle F. Angle EFC is equal to angle ADC. This is 90 degrees. Okay. This is 90 degrees. And the third angle will be equal. So angle FEC is equal to angle DAC. Okay. The third angle will be equal. So triangle ACD. Triangle ACD is similar to triangle EFC. See, we have to write the correct order. Angle A is equal to angle E. Okay. And C is equal to C and D is equal to F. Okay. These two triangles are similar. And if triangle ABD is congruent to triangle ACD and ACD triangle is similar to triangle ECF. So from these two statements, we can say that triangle ABD is similar to triangle ECF. Okay. Next one. In the given figure, CD is the perpendicular bisector of AB. Okay. EF is perpendicular to CD and AE intersects CD at G. We have to prove this one. See here CD is the perpendicular bisector of AB. That means CD bisects AB also. So BD is equal to DA. And angle CDB, this is 90 degrees and EFD is 90 degrees. Okay. EF is perpendicular to CD and BD is perpendicular to CD. So EF will be parallel to BD. Okay. Now we will compare the triangles CEF. We will compare the triangle CEF and triangle CBD. Okay. Angle C is common. So angle C is common and angle CFE. Angle CFE is equal to angle CDB. This is 90 degrees. Okay. And the third angles will be equal. So angle CEF is equal to angle CBD. Okay. See, the corresponding angles of these two triangles are equal. So these two triangles are similar. Triangle CEF is similar to triangle CBD. See, we have to write the correct order. Angle C is equal to angle C, E is equal to B, and F is equal to D. Okay. These two triangles are similar. And now we will compare the triangle EFG and triangle GDA. Okay, we will compare these two triangles. Angle EGF is equal to angle DGA. These two angles are equal because these two are vertically opposite angles. And EF is parallel to BD. EF is parallel to BD. So angle FEG, this angle will be equal to GAD angle. Angle FEG is equal to angle GAD. Why? These both are alternate interior angles. Okay. And the third angle, angle F is equal to angle D. Angle EFG is equal to angle GDA. It is 90 degrees. See, the corresponding angles are equal. So, these two triangles are similar. We should write the correct order. Triangle EFG is similar to triangle. See, angle E is equal to A. Okay. And F is equal to D. Okay. And G is equal to G. Okay. So triangle EFG is similar to triangle ADG. Okay. So from this similarity, what can we write? The ratio of the corresponding sides are equal. So EF divided by AD is equal to FG divided by DG. Okay. And from this similarity, what can we write? CE divided by CB is equal to EF divided by BD is equal to CF divided by CD. Okay. And we have here BD is equal to DA. So here we'll substitute BD is equal to DA. We will get EF divided by DA is equal to CF divided by CD. Okay. See, from these two equations, we have EF divided by DA. These both are common. So from these two equations, we can have CF divided by CD is equal to FG divided by DG. Okay, this is what we have to prove. Next one. In the given figure, ABCD is a parallelogram. BE bisects CD at M. See, BE bisects CD at M. That means DM is equal to MC. DM is equal to MC. And intersects AC at L. Prove that EL is equal to 2BL. Okay. So, in parallelogram, opposite sides are equal. So, here AD is equal to CB and CD is equal to AB. Right. Now, we will compare the triangles DEM. Triangle DEM and triangle MBC. MBC. See here, this angle DME is equal to angle CMB. Angle DME is equal to angle CMB. These both are vertically opposite angles. And the opposite sides in parallelogram are parallel. See, when AD is extended to point E, it becomes AE. So here AE is also parallel to CD. Okay. Angle EDC, this angle is equal to angle DCB. So angle EDC is equal to angle DCB because these both are alternate interior angles and DM is equal to MC. So by using angle side angle property, we can say that these two triangles are congruent. Triangle DEM is congruent to triangle CBM. Okay, we have to write the correct order here also. See, angle D is equal to angle C and angle E is equal to angle B and M is equal to M. Now we will compare the triangles AEL and triangle LCB. Okay, we have to prove that EL is equal to 2BL. Okay, EL we have in this triangle AEL. Okay, we have in this triangle and BL we have in triangle CLB. Okay, this one. Okay, so we will compare these two triangles now. Angle ELA is equal to angle CLB. These two are vertically opposite angles. So angle ELA is equal to angle CLB. Okay, and AE is parallel to BC. So angle EAC is equal to angle ACB. Okay, angle EAC is equal to angle ACB. These both are alternate interior angles. Okay. And the third angle, angle AEB, angle AEB is equal to angle EBC is equal to angle EBC, because these are also alternate interior angles. Okay, the corresponding angles are equal, so these two triangles are similar. We have to write the correct order. Triangle AEL is similar to triangle A. Angle A is equal to angle C, and E is equal to B, and L is equal to L. Okay, these two triangles are similar. Okay, now the ratio of the corresponding sides are equal. So AE divided by CB is equal to EL divided by BL. And we have proved these two triangles are congruent. So the corresponding sides are equal. So here DE is equal to BC. So DE is equal to BC is equal to AD. See here DE is equal to AD. Okay. So what is AE here? AE is equal to AD plus DE. AD plus DE. Okay. It is AD plus DE is AD. Okay. It is 2AD. So AE is equal to 2AD. We'll substitute here. We will get AE is equal to 2AD divided by CB is AD. Okay. Divided by AD is equal to EL divided by BL. Okay. Here we have EL is equal to 2BL. Okay. We have proved it. Next one. In the given figure, DE is parallel to BC. DE is parallel to BC. The value of X is what? Okay. Now, if DE is parallel to BC, then angle ADE is equal to angle ABC, because these both are corresponding angles. Angle ADE is equal to angle ABC. Okay. And angle AED, this angle is equal to angle ACB. These both are also corresponding angles, is equal to angle ACB. Okay. Okay. And angle A is common. Angle A is common. So the corresponding angles are equal. So these two triangles are similar. Triangle ADE is similar to triangle ABC. We have to write the correct order here. See, if these two triangles are similar, then the ratio of the corresponding sides is equal. So AD divided by AB is equal to AE divided by AC is equal to DE divided by BC. Okay. Now we have the values of AD and AB, and we have the value DE. We have to find BC value. Okay. From here AD is equal to 2, and what is AB? See, AD plus DB, it is 5 centimeters. AB is equal to 5 is equal to DE is what? 4 divided by BC is X. So here X is equal to 20 divided by 2. It is 10 centimeters. That's all for this video. I hope you like it. Please like, share and subscribe. Thank you.